In this video, you will learn how to simplify, multiply, and divide radicals. Now, to simplify radicals, what we're doing is we're trying to break down a radical that might not be a perfect square and break it down to simplify it so that we can reduce or cancel things within fractions or combine things with other radicals. So for example, if we had the square root of 196 and you're trying to simplify this, now you might recognize this as a perfect square, and it does work. If you do not see it like that, what I can do is I can break apart the 196 as a product of two or more numbers. So if I can recognize this as a product of 4 times 49, I can break it apart like this. Alright, and I probably could get that because 196, can be divided by 2, and then you can divide it by 2 again to get 4, and so 4 times the 49 would give me 196. Alright, well from here, using this first method, what I can do is I can separate this into two radicals, where I have the square root of 4 times the square root of 49. Well, the square root of 4 we know to be 2, the square root of 49 we know to be 7, so now we have 2 times 7, which is 14. And notice that would be my correct answer. Alright, the square root of 196 is 14 because 14 squared is 196. So this is using method 1, where I break down the original number as a product of one or two numbers that are perfect squares, and then separate them to simplify. Now the next one is not a perfect square. We have the square root of 32. I can think of this as a product of a perfect square and a number. So I can see this as 16 times 2. So I can think of this as the square root of 16 times 2, and I know the square root of 16 is a perfect square. So what I can do is I can separate this as the square root of 16 times the square root of 2. And the square root of 16 we know to be 4, so this would be 4 times the square root of 2. So this here is my simplified form of the original expression. Alright, next we have 2 times the square root of 48. So to simplify, I can basically ignore the 2 for now and look at the 48. Now 48, we can see that as a product of 16 times 3. And I chose 16 because 16 is a perfect square. So when I separate this into two radicals, I have the square root of 16 times the square root of 3. And the square root of 16 we know to be 4. So I can think of this as 2 times 4 times the square root of 3. 2 times 4 is 8. So my final simplified form is 8 times the square root of 3. Okay, this is one method or one way to simplify a radical. But there are other ways that you can think through this. Here's a second method. Now let's say that we have something inside the radical and it's already factored down for us. So maybe we have 8 broken down as 2 times 2 times 2. What I can do is I can pull numbers out of here. So if I see something repeated, like right here, I see a group of 2, I can pull 1, 2 out because I have one group of 2's, I pull out 1, 2. And I'm left with now just this other 2 left over. So my answer would be 2 on the outside times the square root of 2. Alright, so let's just look at a few more examples. Here we have now 4 2's on the inside. So I'm looking for groups of things that I could pull out. Here's a group of 2's, and here's another group of 2's. So I have one group of 2's, so I pull out 1, 2. So now those are gone. Here I see another group of 2's, so I can pull out another 2. So now these 2's are gone. So I have nothing left over inside the radical. All I have is 2 times 2 on the outside, which is going to be 4. So my solution is 4. Okay, another example. Here we have 5 2's. So here's a group of 2 2's. Here's another group of 2 2's. So for each group, I pull out one of them. So here's one group, so I pull out 1, 2. Here's another group, I pull out another 2. So now those are gone. I have 2 times 2 on the outside, and then a 2 left over that is not paired up with anything on the inside. So 2 times 2 is 4. So my simplified form is going to be 4 times the square root of 2. Okay, here are some more examples. Now we have 3's and 2's on the inside. So what I can do is look for groups of 2 things. So here we see one group of 3. So I pull out 1, 3. And here's another group of 2's. So I can pull out 1, 2. So I have a 2 and a 3 on the outside and nothing on the inside. So 2 times 3 is 6, which is my answer. Here's another one. Now we have 3 3's and 2 2's. I look for groups of 2 things. So here are 2 3's. So I can pull out 1, 3. Here's a group of 2's. So I can pull out 1, 2. So I have 2 times 3 on the outside, and then a 3 on the inside left over. So 2 times 3 is going to be 6 on the outside, and then a square root of 3 left over. So those are the 2 different methods. And now at this point, I'm going to compare the 2 methods for you, and we're going to have our example to be the square root of 75. All right, so method 1. Method 1 was to try to figure this out as a product of a perfect square and a number. So I can think of this as the square root of 3 times 25. I chose 25 because when I separate them into 2 radicals, the square root of 25 we know to be 5. So I have the square root of 3 times 5, which can be written better as 5 times the square root of 3. So this is method 1. Method 2. If you have the same radical, the square root of 75, I'd have to begin by factoring down so that it looks like the previous examples we saw in the other slides. So 75 is a product of 3 times 25, and 25 is a product of 5 times 5. So 75 I can think of as a product of 3 times 5 times 5. Now using this method 2, I look for groups of 2 things, and here we see 2 5's. So I pull out 1 5 because I have one group of 5's. So now I have 5 on the outside and a 3 left over on the inside to give me 5 times the square root of 3. Let's look at another example. Here we have the square root of 24. The square root of 24, using method 1, I can think of this as a product of a perfect square times a number. Well, 4 is a perfect square, so if I can write this as the square root of 4 times 6, then I can separate this as the square root of 4 times the square root of 6, and the square root of 4 we know to be 2, so we have 2 times the square root of 6. And I can write this if I wanted to without that multiplication sign. Okay, using method 2, with the same number, I'd have to break down 24 as a product of 4 times 6. 4 is 2 times 2, and then 6 is 2 times 3. So I can write this as 3 2's and 1 3 being multiplied together. And using method 2, I look for groups of 2 things. So here we see 2 2's. So there's one group, so I pull out 1 2. There's nothing else that have groups of 2 things, so I just leave the 2 times 3 on the inside. So I have 2 on the outside, and then I have the square root of 6 left over. So now we have learned how to simplify radicals. Next, we need to learn how to multiply and divide radicals. Now to multiply radicals, we can kind of already see this with our first method right here. So we see right here, if we have the square root of 4 times 6, we can break it apart as a product of 2 radicals, right? So we've done that before for method 1. So if you're trying to multiply something like the square root of, let's say, 7 times the square root of, let's say, 3, I can combine by putting into the same radical as the square root of 21. So basically, when you see a multiplication, I can either combine into one radical or separate into 2 radicals. So here's another example. We have the square root of 5 times the square root of 5. When I multiply, I can combine into one radical. So I get the square root of 5 times 5, which would be the square root of 25, which would be 5. Okay, if you had the square root of 2 times the square root of 8, I can combine into one radical to get the square root of 2 times 8, which is the square root of 16, which would equal 4. So combining radicals like this will help me to simplify my expressions, because right here, okay, this is not the most simplest of forms, but I can combine by multiplying to get 4, which is very simple. Now, if you're multiplying two radicals together, there are different ways that I could think through the process of simplifying after I multiply. For example, method 1. When I multiply, I can combine by getting the square root of 3 times 27, which would be 81. And the square root of 81 we know to be 9. All right, so this one, method 1, is clearly going to be probably the easier method to do, but there are times when the second method might be simpler. So using method 2, if I have the same problem, what I can do is when I multiply, I don't actually multiply yet to get 81, because using method 2 is when I break down and factor the numbers inside. So if I multiplied to get 81, I'd have to break back down right away to get 9, 9, and then 3, 3, and then another 3, another 3. But that's kind of extra work. What I can do is just take the 27 and go from there to get 9 times 3. 9 is 3 times 3. So the 27 is 3 times 3 times 3. So I have 3 3's from the 27 along with the other 3 in the front. So in this particular example, it's not really a big deal to use method 2, but it might be simpler in many cases. Instead of multiplying to get some big number, you can just leave it like this and break down the smaller number of 27. And then from here, we look for groups of 2 things. So here's one group, 2 groups. So I pull out 1, 3, and then another 3. So what I have is 3 times 3 on the outside, which is 9, and then nothing on the inside. Now here's an example where using method 2 would probably be easier. We have the square root of 30 times 3. So to combine, to multiply, I'm going to get the square root of 30 times 3, which is 90. And then from here I can break it down and factor, or I can do it trying to find a perfect square that would multiply to get the 90. But let's break this down. 90 you can break down as a product of, 2 times 45. 45 is 9 times 5, and 9 is 3 times 3. So what I have is 2 times 3 times 3 times 5. So when I simplify, I look for groups of 2 things. So here are 2 3's that I can pull out. So there's one group, so I pull out 1 3. So I have 3 on the outside, and then 2 times 5, or 10, on the inside. So using method 2, when we multiply, we would not actually multiply to get 90 yet. We would just leave it at here with a 30, and break down the 30 as 3 times 10, and 10 is 2 times 5. So now I have 3 times 2 times 5 times this 3 right here. And notice I get the same thing, but it's a little bit quicker when I have to factor down. Because if I factor 30 down, this number is much smaller to work with than the 90. So in this case, it's still not a big difference between the two, but it is a little bit quicker if you don't multiply out and just from here factor down. And again, we're going to get 3 times the square root of 10. If you decided not to factor and to try to find it the other way, what you do is you do the square root of 30 times 3 to get 90. Then ask yourselves, what perfect square would multiply with another number to get 90? Well, if I choose 9, 9 times 10 is 90, and I chose 9 because when I separate, the square root of 9 is a perfect square, which is going to be 3. So I have 3 times the square root of 10. So any of these methods are okay. So I'm taking the time to show you all these different ways to think through this, and then you can be the judge and decide which one is easiest for you to use. Now again, with multiplying radicals, what if there's a number on the outside? So like 2 times the square root of 3 times 4 times the square root of 3. Well, what I can do is I can rearrange this if I want to. And you don't have to actually physically rearrange, but in your head you can rearrange the order of multiplication. Because this says 2 times square root of 3 times 4 times the square root of 3. This is all multiplication. So when you multiply, multiplication is commutative, meaning you can change the order. So if I wanted to, I can write this as 2 times 4 times the square root of 3 times the square root of 3. So I just changed the order of the multiplication. And then 2 times 4 is 8. And then the square root of 3 times the square root of 3 would be the square root of 3 times 3, which is 9, which would be 3. The square root of 9 is 3. So 8 times 3 would be 24. Now again, you don't have to actually physically rewrite this problem here at this step, but in your head you can think the 2 times 4 gives me 8, and then the square root of 3 times the square root of 3 would give me 3, then multiply 8 times 3 to get 24. Now lastly, we need to work with fractions. So if you're dividing radicals, here's what we can do. So just like when you multiply, you can combine into one radical or separate into two radicals. Same thing with division or with fractions. What I can do is, to simplify, I can break this apart into two radicals where I have the square root of 3 over the square root of 16. So I can break it apart, and then on the bottom, this square root of 16 we know to be 4. So my solution is the square root of 3 over 4. Example 2, we have the square root of 7 over the square root of 25. To simplify, I can break up into two radicals, the square root of 7 over the square root of 25, and the square root of 25 we know to be 5. So we have the square root of 7 over 5 as my solution. Here is a third example. We have the square root of 16 divided by 81. So for this one, I can separate again into two radicals, the square root of 16 over the square root of 81. The square root of 16 is 4, the square root of 81 is 9, so my solution is 4 over 9. One more example, we have the square root of 8 over 9. Again, I can break up into two radicals, the square root of 8 over the square root of 9. Well, the square root of 9 we know to be 3, and then on the top, the square root of 8, I want to simplify that. So the square root of 8, I can think of 8 as 2 times 2 times 2. I look for groups of two things. Here's a group of two 2's, so I pull out 1 2, because there's one group. I'm left with 1 2 on the inside. So on the top, I have 2 times the square root of 2, and on the bottom, I have 3. And always check at this point if there's anything that can reduce, make sure that you do that. Alright, so if there's something in the bottom, like maybe an 8, for example, you could do like 2 divided by 8 to get 1 over 4. But in this case, nothing can reduce, so that would be our solution. And that concludes our lesson for today. We will see you next time.